The size of an atom is only a few angstroms. There are 10 billion angstroms in 1 meter. When you think of an atom, you probably picture something like this. On the outside, you've got electrons that have a negative charge. In the middle is the nucleus. It's made of neutrons which have no charge and protons which have a positive charge. This model's a good starting point, but there are a few things here that don't quite agree with modern science. For one, the size of the nucleus is a lot smaller than this. If I animate it to scale, you wouldn't even be able to see it. The same thing with these electrons. Another thing that's inaccurate is that electrons orbit the nucleus just like a planet orbits a star. Unfortunately, this is still taught in many textbooks, but it's just not correct. Over 2,000 years ago, ancient Greek philosophers had this idea that everything was made of tiny particles. They called these tiny particles atoms. It wasn't until the 1800s that we finally started using science to prove that these atoms really exist. First, we thought atoms looked like this: a positively charged sphere with negatively charged electrons floating around it. Then we learned that this positively charged sphere was actually a lot smaller. We called this the nucleus. Slowly but surely, we learned that the nucleus is made up of protons and neutrons. These electrons were tricky. At first we thought, they have to be doing something, so they probably revolve around the nucleus like this. Electrons were then discovered to have different energy levels. We call these shells. Shells can only fit a certain amount of electrons. The more electrons, the more shells. It didn't take long before we realized that these shells don't determine how close the electron is to the nucleus. As it turns out, electrons are a lot more unpredictable. So if electrons don't orbit the nucleus, what do? Let's start with an idea of an orbit. Here we have the Earth going around the Sun. If the Earth is here today, we can use the laws of physics and gravity to predict exactly where the Earth will be 3 months from now. We know both where the Earth is and where it's going. Now let's go to the size of an atom. With an electron, things are a little different. We can't know exactly where it is and where it's going. We can only know one or the other at any given time. This means it is impossible to really know what the electron is doing. The best we can do is predict where the electron will be found. This area is most commonly known as the electron cloud. However, if we want to be more specific about where to find electrons, you'll need to know about orbitals. This is not the same as orbit. Orbitals are specific shapes where electrons live in. If you were in a college chemistry class, you'd be studying about how these orbitals fill up as you get more electrons. So in short, electrons are uncertain. We can't know the path that they travel, only that they'll be found here in the electron cloud. So now you know that even though this is a popular way to represent an atom, it can be misleading. Just to recap what we learned, everything is made of atoms. Atoms are incredibly small, the nucleus is even smaller, and electrons don't orbit the nucleus. Their path is unpredictable. Thanks for watching, everyone. My name is Jared Owen, and I'll see you next time.